For our project, we decided to reconstruct the Hierapolis Sawmill. This water-powered machine is from the 3rd century AD and was used to reduce the amount of labor necessary to cut through large blocks of marble. One of its main innovations lies in its ability to harness the power of rotary motion and translate it into reciprocal linear motion. As the mill was made entirely of wood, no physical evidence survived. Our main evidence of this machine lies in an inscription on the tomb of Marcus Aurelius Ammianus in Hierapolis. As the image on this inscription is not highly detailed and does not convey depth, we relied on a proposed reconstruction by Paul Kessener for our building plans. We started our structure by building a prototype of our water wheel. For our first attempt, we had divided the wheel into 16 barrels using a ruler and guesswork to place each of the panels. This method was imprecise, and we decided to try again. On our second attempt, we calculated and drew out a geometrical pattern on one half of the wheel, again with 16 barrels. This time, the panels were evenly spaced out and all set at matching angles.
Next, we built the saws and their connecting arms. These elements were the most intricate to build, as they consist of many moving pieces. For the saw themselves, we used one rod straight through which connected to the strong metal joint in the arm. We inserted a support beam above this and used thin wire instead of a saw blade. This wire was then tightened and held in place with small pins on either side. Once all the pieces were constructed, our next task was to align the gears and fix our beams into their support blocks. This task was difficult and required a lot of trial and error. The holes that we had drilled through the support blocks did not allow the beams to move freely at first, but we were able to fix this easily by gradually sanding the insides of the holes. We also had to make minor adjustments to the lengths of the gear teeth, as they kept getting caught on the panels of the adjacent gear. This was our result.
We encountered several challenges while constructing this model. Firstly, we found it difficult to ensure that the rods would pass through the exact center of each circle. If the rods were not passing through the exact center, the circular parts would not turn uniformly, and thus the machine would not be able to function. This is particularly important for the gears. The teeth of the main gear need to be of uniform length, and the recesses of the second gear must be measured precisely to accommodate each tooth without halting motion. The water wheel and gears must be fixed to the transverse beam connecting them. We were able to use hot glue to resolve this issue and fix the pieces together. However, ancient builders would have required skilled woodworking or specific techniques for this task.
Secondly, it must be taken into account that the force of the water powering the machine must be strong enough to turn the wheel. With this in mind, the builder must also remove as much opportunity for friction as possible. For example, the revolving beams must have the ability to move freely within their supports. One area where we found it difficult to remove friction was in the supports for the saws. These supports were not present in the tomb inscription. However, Kessener proposed that they were necessary, as it is assumed that the saws would need to be guided in order to cut uniform lines. These supports would have needed to be perfectly constructed to keep the saws vertical and straight, preventing any sidelong movement. We found it difficult to ensure that the saws were supported without being restricted. We resorted to using props and elastic bands to create an even and supportive channel for the saws. Finally, the saws are connected to the gears by long arms which are connected by a pin to convert the rotary motion into horizontal motion. As these arms are long and heavy, we found that they tended to pull the saws off balance. To counteract this, we added small supports on either side of the arms to guide them as they pushed the saw back and forth.
It is difficult to assess the use and success of machines like the sawmill because they are built of organic material and do not preserve in any physical form in the archaeological record. There is later evidence for water-powered sawmills in both Ephesus and Gerasa. However, these designs did not incorporate the complicated gear system seen in the Hierapolis design and worked to power one saw on either side of the water wheel. While the Hierapolis mill allows greater potential for efficiency by working two saws on only one side, this technology was highly complex. After building the machine and seeing how tricky the gears and cranks were to set up, we hypothesized that the concept for the mill was well received. However, the design was simplified to allow for ease of transmission and construction.